Good morning students. Today we are going to see the new topic gravitation. The first one, introduction. We are amazed looking up the glittering sky. We wonder how the sun rises in the east and sets in the west. Why there are comets or why stars twinkle. The sky has been an object of curiosity for human beings from time immemorial. We have always wondered about the motion of stars, the moon and the planets from Aristotle to Stephen Hawking. Great might have tried to understand the movement of celestial objects in space and what causes their motion. The theory of gravitation was developed by Newton in the late of 17th century. He explained the motion of celestial object and terrestrial object. In spite of the study of gravitation and the effect of celestial objects spanning last 3rd century, gravitation is still one of the active areas of research in physics today. In 2017, the Nobel Prize in Physics was given for the detection of gravitational wave, which was theoretically predicted by Albert Einstein in the year of 1915. We are understanding the planetary motion, the formation of stars and galaxies, and recently massive objects like black holes and their life cycle have remained the focus of study for the past few centuries in physics. Geocentric model of solar system. In 2nd century, Claudius Ptolemy, a famous Greco-Roman astronomer, developed a theory to explain the motion of celestial objects like the Sun, Moon, Mars, Jupiter, etc. This theory is called geocentric model. This model explains the Earth is at the center of the universe and all the celestial objects including the Sun, Moon and other planets orbit the Earth. This geocentric மாடல்ங்கிறது எர்த்தை சென்டரா வச்சு மற்ற பிளானட்ஸ் அதை சுற்றி ரிவால்வ் ஆகுது. Ptolemy model closely matched with the observation of the sky with our naked eye. But later astronomers found that even though Ptolemy model successfully explained the motion of sun and the moon up to a certain level, the motion of the Mars and Jupiter could not be explained effectively. Ptolemy sun and moon உடைய மோஷனை சக்சஸ்ஃபுல்லாக எக்ஸ்பிளைன் பண்ணி இருந்தாலும் அவரால் மார்ஸ் அண்ட் ஜூபிட்டருடைய மோஷனை அவரால் எக்ஸ்பிளைன் பண்ண முடியல. இது டிராபேக் ஆஃப் Ptolemy மாடல். The next one, heliocentric model of Nicholas Copernicus. In the 15th century, a Polish astronomer Nicholas Copernicus proposed a new model is called heliocentric model. The heliocentric model states that the sun was considered to be at the center of the solar system and all the planets including the earth orbited the sun in circular orbit. This model successfully explained the motion of all celestial objects. The next one, history of gravitation. The first scientist Galileo. During the same period of Copernicus, Galileo, Italian physics discovered that all objects close to Earth were accelerated towards the Earth at the same rate. The second scientist, Tycho Brahe. A nobleman, Tycho Brahe spent his entire lifetime is recording the observation of the stellar and planetary position with his naked eye. Next scientist, Johannes Kepler, analyzed the data completed by the Tycho Brahe and deduced the law of planetary motion. These laws are termed as Kepler's law of planetary motion. Now we are going to see the topic Kepler's law of planetary motion. Kepler explained the 3 laws of planetary motion. The first one, law of orbit. The second one, law of area. The third one, law of period. The first one, law of orbit. The law states that each planet moves around the sun in an elliptical orbit with sun at one of the foci. அதாவது சன்னை சென்டரா வச்சு எல்லா பிளானட்ஸும் அதை elliptical orbitல revolve ஆகுது. The closed point of approach of the planet to the sun P is called perihelion and the furthest point A is called aphelion. The semi-major axis A and the semi-minor axis is B. In fact, both Copernicus and Ptolemy considered planetary orbit to be circular, but Kepler discovered the actual orbit of the planets are elliptical. The second one, law of area. This law states that the radial vector line joining the sun to a planet sweeps equal area in equal interval of time. In this figure, the white shaded portion in the area del A swept in a small interval of time del T by a planet around the sun. The sun is not at the center of the ellipse. The planet travel faster when they are nearer to the sun and slower when they are further from it to cover equal area in equal interval of time. Kepler discovered the law of area by carefully noting the variation in the speed of planets. The third one, law of period. The law states that the square of the time period of revolution of a planet around the sun in its elliptical orbit is directly proportional to the cube of the semi-major axis of the ellipse. Therefore, this equation can be written as t square directly proportional to a cube. We are removing the proportional term, adding constant term. Therefore, t square by a cube is equal to constant. T is the time period of revolution for a planet and A is the semi-major axis. The law implies the distance of a planet from the sun increases. The time period also increases but not at the same rate. The table shows that the time period of revolution of the planet around the sun along a semi-major axis are given. We can realize that d square by a cube is nearly constant.